Book 11's, basically all that's left to do now is just to quickly summarize the rules of reduction that we have learned. Now they seem like you have so much to remember, and the 90 plus and the 90 minus, and the good news is this boils down to two very, very simple questions. First of all, just to note that to work in quadrant 1, if you do 90 degrees minus an angle, that would land up in quadrant 1. To work in quadrant 2, you could do 90 degrees plus theta, or you could do 180 degrees minus theta. That would land up with you an angle in quadrant 2. In quadrant 3, we would do 180 degrees plus theta. Now you would have noticed that we haven't spoken at all about 270 minus. Now technically, 270 degrees minus an angle is also a way to work in quadrant 3. Now they're no longer allowed to examine that, and so you'll never see a question that says 270 minus theta. However, if for some reason it pops up, don't forget that you can always add 360 or minus 360, and the truth of the matter is that 270 behaves exactly like 90 degrees. So you can always use the same rules for 90. In the fourth quadrant, we would use 360 minus theta, which would land you up with an angle in the fourth quadrant. And again, technically, 270 degrees would land you up in the fourth quadrant. However, we don't examine that anymore. But it would have exactly the same rules as the reduction from 90. So, last thing we need to remember is that we need to remember the all stations to Cape Town. Basically, all trig ratios are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, and cos in 4. So if we know what quadrant we're working in and how the 90 minus and 90 plus works, basically it comes down to two questions. The first question I always ask myself in any reduction question is, what is the sign of my reduced ratio? And basically the sign comes from what quadrant you're working in. So if you figure out what quadrant you working in based on the picture that I've drawn. So if it's 90 minus, you work in quadrant 1. If it's 90 plus, you work in quadrant 2. So the first thing I do is I ask myself, what is the sign of the reduced ratio? So what quadrant am I working in? And then I look at all stations to Cape Town. So before I've even considered going forward, I always think about the sign. And then the second thing I say to myself, what happens to my name? What ratio am I using? Does it stay the same or does it change? Now, the reason why I always decide my sign first is otherwise, if the name changes, then sometimes people start to get confused. Must I decide the sign based on the new name or the old name? And so that's why I always decide whether it's positive or negative based on the quadrant before I even consider whether it stays with the same name. Now, why would you stay with the same name? We learned that you stayed with the same name if you did 180 degrees plus or minus theta, or if you did 360 degrees plus or minus theta. So the moment you're working from 180 or 360, if the original question was sine of an angle, then the reduced answer is sine of an angle. When would my name of my ratio change? If you're working with 90 degrees plus or minus theta, your name of your ratio always changes to the co-ratio. Now, in actual fact, that's exactly the same rule for 270 degrees. So even though we haven't discussed 270 degrees, it behaves in exactly the same way as 90. So if you were doing cos of 270 plus theta, that would then change to sine of theta. And so 90 and 270 are where you change names to the co-ratio. So cos would change to sine, and sine would change to cos. That's why they're called co-ratios. Now again, let me just state that 270 degrees plus theta is not really an examinable concept, and so chances of you ever seeing it are quite small. But If you do, you now can deal with it because it behaves exactly the same way as 90. So, quick summary. Only rules you have to learn are the following. The moment I see a reduction, I say to myself, right, is this going to be a positive or a negative? That depends on what quadrant you're working in with your angle, and then you use all stations to Cape Town. Once you've decided the sign, your second thing you say to yourself, does my name of my ratio that I'm working with stay the same? And the answer is yes, if you're working from 180 or 360. Or does it change, in which case you must be working from 90 or 270. Then cos would change to sine, and sine would change to cos. Now basically, those are the two things that I process every time I do a reduction. Every reduction question I do, I say, right, what's the sign? Figure it out. Does my name stay the same or change? Write it down. It means that your reduction becomes really quick and easy, because all of the reasons we've discussed around why the name stays the same and why it changes, that's really important to understand. However, when we're looking at a question, we don't have to go through the whole process of rationalizing that. We can just use our 2 steps. Right, I'm hoping that you are going to love reduction from now on. Well done, grade 11s. Keep going.